Hello, Okuma fans! Hey, this is Charlie with the Gossager Applications staff once again. Another video for you requested from the YouTube community that was asking how to manipulate or synthesize a parts counter on Okuma turning centers. Great question. I've seen a lot of different makeshift models of parts counters, but I've also seen the way Okuma wants us to do it, and well, I'll throw it out to you guys, show you everything I know, and let you decide which one you like to use the best. We're going to go down four avenues here. The first is the way Okuma suggests we count parts, and then two more methods that I've seen work in the field. A little more complicated, but also a little more fun too. So the first thing I want to point out is that under your soft keys, normally when you're running a program, you're probably looking at this value of soft key right here. If you arrow over one time, you'll notice that F6 populates with a word NC operate monitor. By touching that, wow, look at this. Here is a work counter. And by the way, just as long as we're talking about it, I am going to simply touch page down on my keyboard, and that NC operate monitor turns into a series of timers. These will let you know, the amount of cutting time on the machine, the amount of time the spindle's been turning, power on, so forth and so on. It's a great little test to see how long your machine's been running. This is not expected to be the permanent, the odometer, if you will, because it can be reset if you want it to. It's not the tattletale that some people might think it is. But let's go back page up to our work counter and explain what we've got going on here. Okuma gives us four independent counters that we can use in conjunction with one another, or we can just set them and forget them. On the left side, we've got the count column, and this one belongs to the machine. Every time the machine encounters an M2 or M30, the count is going to increment up by 1. In all four categories, it'll automatically go up. In our set column, we can populate how many parts we want to make before the machine alerts us that we've reached that. So obviously we can have four different values here, or in our case we're just going to use one. Now, just in case you're having a difficult time envisioning why this is important to have four, imagine if you have you're using a bar puller instead of a bar feeder, so you will need to know how many parts there are per bar, as well as how many parts there are in a run. So I could set my work counter A to be the number of parts that I have in a bar. Let me turn on my numbers lock so it'll actually set. So that's the number of parts that I have in a bar, but I also want to have the number of parts in this run. So now once I make 30 parts, I can have the machine alarm out and tell me that, hey, you know what, you need to put a new bar of material in there, but it won't reset the overall production of the count. That's kind of nooky. So again, as I mentioned a minute ago, the machine will automatically increment all of these counts when it hits an M2. I just jotted up a program quickly in Advanced One Touch that is, it's just a rough turning cycle, an OD thread, and there's nothing special in here, just your basic stuff. So I'm going to run through that just to show you what it'll do. And cycle slam, when we start functioning. There's about 7 passes to this, so it's not totally abnormal, but let's go ahead and look at our NC operate monitor, and as soon as this encounters the M2 at the end of the program, there's our increment. Hit start again, and it will do exactly the same thing, once again incrementing all four columns. Because I don't have a value in my set column, the machine will never tell me that I've exceeded my number of parts to be made. But let's just say I want 4 parts and then an advice that I've achieved that. So coming back to my operate monitor, I do not have to have this up. It will monitor even if it is in the background. So let's get our M2 here. I'm going to speed it up a little bit so that we can not lose everybody. Now that after we make this last part, we're going to get a C-level alarm come up on the screen that says, bonk, work counter over. Now for those of you that are familiar with the 4 different levels of Okuma alarms, a C alarm is not going to interrupt the machine while it's running, but as soon as it hits the M2, it becomes an alarm that cannot allow function to continue until the conditions are satisfied. So in our case, what we would have to do is say, okay, I either have to increase my set number or set my count to 0, and now the work counter can be reset. I'm off on my way. Alright, that is the way Okuma is expecting us to do things. And I can hear people hollering up a storm right now. Hey, wait a second, wait a second, wait a second. I have a bar puller or a bar feeder. So what in the world am I supposed to do about the fact that a looping command at the end of this program, something that causes the machine to make perpetual parts, will eliminate the M2 so nothing is indexing my part count? Well, okay, Okuma is smart enough to have thought of just about everything here. Their suggestion is that we use what's called an SDF program, or a schedule program. My regular part program is still made exactly as you just saw it run, with an M2 terminating. No special loop. FANUC guys use M99 to go back. We're going to experience a couple of different Okuma methods here in a second, but it's just a standard one part program, and then we will create a new program called SDF instead of .min. And what the schedule program, or SDF, looks like is the word pselect. That means, yep, exactly what it sounds like, program select. Then there's the name of the program we want to pick up. In my case, it was loop.min that you see right there. Then I have 3 little commas. I'm not going to go into each one of those. Basically what those are all about is the program located in a different directory? Is there some subprograms that go along with it? Stuff we don't really need. But I have 3 commas to represent there are no values that I have that Okuma wants to know about in between. But at the very end of that, a Q that represents the number of times to call up that program. So I'm saying program select my loop.min, no subs, no directory, no nothing, but do it 5 times and then end the SDF program. Now we're getting somewhere. So when I do my program select, most people haven't paid much attention to these tabs that are up on top of the program select page. I'm going to touch the word schedule select, and it'll show me my looping subprogram. By selecting that, it automatically split the screen for me. There is my schedule program that you just saw, and over here is going to be my main program. Before I launch into this, I'm going to make sure that my set is something low enough that it'll expire and we can see how it works. But auto and cycle slam, there is my schedule program, and now I'm making the part program. Let's go ahead and call up our operate monitor, and I'm going to put it up over here where we can see it. Notice that it went on about its way and it's making a second part even though there's an M2. Now it's satisfied the count. I'm going to set that a little higher. Oops, hello. NC operate. We're going to set that at 10 just so that we can see the function of the schedule program. I still have told this, make 5 parts and go. And so it will just make a continuous loop until the work counter is satisfied. Now in our case, it's going to get all the way up to I don't know if I reset the counter there, but it's going to make 5 parts, and then it's going to stop because it will not have hit the set value. And we're just looping away. Alright, so that's the Okuma preferred method, utilizing the schedule program in conjunction with the parts counter. There, now it made 5 parts and stopped. Alright, so now let's go and experiment with a couple of other different methods. Here's the exact same program, but I have added a couple of little dandies in here. I put a sequence number or sequence name at the beginning of the program, NSTRT. I use that an awful lot, representing the start of the program. Now I'm going to scroll down. I modified no other code in this program until I got to the very end, and you'll see something a little fancy there. Uh-oh, what in the world is this stuff? Anybody ever use system variables out there? Yeah, Okuma has a really great system of variables that uses an acronym starting with the letter V, and they represent certain things throughout the machine. You may have seen the work shift value, the tool number value, the cutter comp value. They can all be referenced by a series of letters that are an acronym for what portion of the system they're talking about. I could go on for years about this, but let's just focus right here on what we're using right now. VWKCC1. What the heck is that? V always stands for variable, and because there are 5 characters, it knows that we're doing a system variable. WK, work, variable, work, counter, count. Oh, how perfect is that? You remember this little, let's zip back over to the front and see variable, work, counter, count. Aha, coolio. So what I'm saying here is that variable, work, counter, count number 1, that's that first column, is equal to whatever used to be in variable work counter count number 1 plus 1. So when the program comes to this line, it's going to read, hey, okay, you want me to set my variable work counter count 1 to whatever used to be in it plus 1. Hey, all right, that's what the machine does automatically when it reads an M2. Gotcha. But because it has a and let's go ahead and ignore this second line for a second, and I just have a loop that says go to end start. So if this command here does not intervene, the program will read go to end start, and it'll jump all the way back to the top and make a new part. This is like using M99 from FANUC, which just loops the program. However, I don't want to do that forever. I don't want to count and loop and count and loop and count and loop until the cows come home. I need something to intervene in this thing. How about the word if, a conditional statement, if the value that's in variable work counter count 1 GE is greater than or equal to, here's another system variable, variable work counter set, VWKCS. So if the work counter count in 1 is greater than or equal to the amount that was in the variable work counter set 1, then skip around this looping command and go to the end of the program. Well, heck, that's easier than snot. So let's select this guy and we will play with it just a little bit and see how it works. So let's come over here. I'm going to change my set, or my variable WKCS. Let's set that to be something like 4. Oh, alarm, alarm, alarm. And we'll reset our variable work counter 1 count to 0. And we can get rid of that split screen. That's not necessary anymore because we're not using the schedule program. All right, cycle start. We're off and running. Now when we start getting down to the bottom, I'm going to single block just so that we can talk through this. Forgive me if you already know. I don't want to beat a dead horse, but we want to make sure we're totally clear on what the heck's going on here. Okay, so now we have variable work counter count 1 is equal to whatever used to be in there plus 1. It was 0, now it's 1. The next click a cycle start is going to analyze this conditional statement and say if the value in the count column is greater than or equal to what's in the set column, go to the end of the program. Well, it's going to analyze it and say this is not greater than or equal to that, so no, this isn't the case. I hit cycle slam, we went back to the beginning of the program. Take off single block, let's let it rock through, and we will single block it one more time once the count gets closer to the set. So there we are with 2. Here we are with 3. And now I am going to let's let it run a little bit more until we get closer to the bottom in X. I don't want to sit here and vamp for the next 25 minutes. There we go. Okay, so now we're very close to the bottom. Boom. It went variable work counter 1 is equal to plus 1. It incremented. Now the alarm C has popped up because it's doing what we told it to. However, as you previously mentioned, the C level alarm is not going to interrupt the function of the program until it reads an M2. So that's where this next statement, if this value is greater than or equal to this value, it's going to skip around this command. And now that's a true statement. So when I hit start, boom, goes to the end. And now I am in an alarm state that cannot move on because the work counter count is greater than or equal to the work counter set. Aha! Clear as mud, right? All right, let's see what happens. Let's go ahead and change this, and I'll show you method number, what are we on now? I believe we are on method number 4. Who's counting, right? Jumping into my program, here is another iteration of the program. Sometimes people have a difficult time understanding these system variables. In case you're wondering, they are listed in the programming manual. This is the CD-ROM that came with the machine, and in the programming manual, that's this guy right here, we have at the very bottom of the appendix, table of system variables, and there is just a whole, whoa, hey, big screen, there's just a whole slew of them. Feel free to take a looky-poo, and hey, alright, all of these can be monitored or manipulated from within your program. Really, really handy. But again, that's something I could spend a whole nother video on. Great, here we go. Now we're going to get a bunch of requests for that one. This time I'm going to use common variables. That's a little easier than system variables. Those of you who have Okuma mills will recognize VC as your call for variables. Lathe guys, you may have seen V's. If I use my parameter button on the control panel, display change, pick up common variable, everybody's seen this page at least once or twice. Okay, so a common variable is simply a value that can be stored in the control and left there even after the power has been cycled, and it can be manipulated either from this page or from inside a program. And the way it gets manipulated inside a program is with the command V1, and then you can either read it or write to it. V1 through V200 are available, so hey, sky's the limit. What I'm doing right here is I'm writing to that common variable page, simply saying that the value I want in variable number 1, that guy right there, variable 1, is 5. I put that in the header of my program so that everyone can, anybody running the program can see, okay, this is where I set the number of parts I want to make before the machine does anything differently. The part program itself is pretty much the same as everything else, but now down here at the bottom, I'm going to set a new value to variable 2. In this case, variable 2 is equal to whatever used to be in variable 2 plus 1. If I go back over to my parameters, you'll see right now it's 0, so as the part is running, it's going to say, okay, variable 2 is equal to whatever it used to be, in this case 0 plus 1. And then here's another conditional statement that simply says, if the value in variable 2 is greater than or equal to what you told me in the beginning is my number of parts made, skip around. If it is not, if that conditional statement is not satisfied, in other words, I haven't made enough parts yet, it reads the word go to end start, and then it will whoop, skip back up here, make another round. Here's a little added something that I always put in this. If the conditional statement is satisfied, in other words, I've made the same number of parts or greater than that variable 1 in the header of the program, skip around here. Let's reset the counter so that nobody has to remember to do that, and then terminate. Let's go ahead and run this and see what happens. Program select, loop 2, OK, and we hit cycle slam after taking off single block. If I look in my parameter page, you'll notice that, oh, hey, it set the number of parts I was supposed to make, but nothing has been set on my variable 2 yet. There, now I just got to the end of the program, it incremented the counter, and I am running like a madman. As soon as variable 2 is equal to whatever's here, then it's going to stop. I am going to kind of fudge it a little bit. Let's add another part in there. Now it's set to 5, and when it gets to the end conditional statement, single block so I can see it. Whoop, too late, it ran through it. But you notice that it went home and it stopped because that was equal to that, and then it reset itself. Clear as mud, right? So there are 4 different methods that you can use to synthesize a parts counter, or just use the one that Okuma has suggested we use. Either which way, there's no excuse for not knowing exactly how many parts your machine has pumped out. So now let's get back to work, shall we? Thanks for watching, and if you have any questions or need further assistance, please give your local Gosiger application